All right, here we go. So we're on 2A.5, exponential and function, context, and data modeling. Essentially, this just means now applying all things that you know about exponentials to real world situations. That's all it means. So you kind of got a sneak preview when you were doing the 2A.2 FRQs, but it was more of arithmetic and geometric sequences, which we learned geometric leads us into what? Exponentials, right? And so it's just a lead into that, but just not in terms of sequence. Okay. So if you are a person who doesn't want to use Desmos, by far, I will definitely help you and do the TI-84 with you. If you plan on being a STEM major in college, most colleges have not leaned into Desmos. So still knowing how and being willing to use the handheld calculator is going to be critical if you plan on going into the STEM field. Okay. All right. So exponentials are tricky. Sometimes the data from exponentials does not look like it's a growth, right? A growth pattern. And that's because you've had a vertical translation take place, right? Something has translated where it doesn't look like a normal pattern of what you would expect. However, we can add and subtract a constant from the output to reveal the proportional growth pattern. So we can manipulate the exponential function, which we talked about in 2A.4. To show us that this was actually a growth function by using our exponential rules, right? And so the other thing that we can talk about is determining exponential patterns from tables. And so when we did this in Algebra 2, we talked about it a little bit in the beginning of AP Precal, but we can identify patterns of exponential functions by doing what? Anyone remembers? Looking at what in regards to the tables. A common difference, right? Now, if we're not a common difference, but a common ratio, right? So typically we can look and determine if there is a common ratio, but we talked about when there isn't a clear common ratio, what that means is that our function has been shifted. A good sign that our function has been shifted is notice right here how our 0 isn't at 1, right? Because our intercept is not at 1. That's a sign that we have shifted vertically or horizontally. Does that make sense? Because all parent functions of exponential functions are going to have a y-intercept at 0, 1. Okay. If I'm not at 0, 1, that means my parent function has had some type of transformation. Does that make sense? Okay. So because of that transformation, you're going to look and determine what may have caused it. So here we have it. Selected values from several exponential functions are given in the table below. For each, find the constant value that can be added/subtracted to the output values to reveal a proportional growth. Okay. So first you're trying to figure out what is the change, and then we find our growth or decay. Does that make sense? Which is back to Algebra 2. We found the difference, and then we found the ratio. Do y'all remember doing that at some point? Finding the common difference and then finding a ratio? Okay, so we're in, well, not a common difference, just a difference. So we're going to be doing that here. So to get from, I want to write. Please stop playing with my emotions. It didn't ding. Okay. So first we're going to find a common, not common, a difference. I'm just going to write difference. So if I'm finding the difference, 13 minus 7 is 6. 25 minus 13 is 12. 49 minus 25 is 24. 97 minus 49 is, what is it? 48, right? 48. So that's my difference. After I find the difference, now I can find my common ratio. So finding my common ratio is going to be done in purple. 12 divided by 6 is 2. 24 divided by 12 is 48 divided by 24 is 2. So I know that this is a growth model with a base of 2. Does that make sense? Okay. And we know our A because your A is your initial. Does that make sense? So A is your initial. So we know that this is our A. And we know it says that there is a translation because it says a constant value that is being added or subtracted. So essentially, we're trying to find the form of y equals a times b to the x plus or minus our d value. So thus far, we have our a and our b. And then to find our d, typically what you can do is choose any point. I always choose the smallest values to figure out what the d value is. Does that make sense? Okay, so I'm going to just use these values. So we have y equals, well, y is 13 equals, what's our a? 7. What's our b? 2. Our x is 1. And we're looking for plus d. What's going to make this a true statement? All right, so I get 13 equals 14 plus d. So what does d have to be? D has to be -1. Can I now write a model for this? Do I have all the parts? Yeah, I have my a, my b, and my d. So now we're going to write our function, our model. So we end up with y equals 7 times 2 to the x minus 1 would be the model for this table. Okay, so what I just did with A, you're going to do in your groups with B and C. I'll be here to check, answer your questions, but I do need you to try and practice in your groups, talk to each other, ask for help. But you're going to do the exact same thing that I did with A, you're doing with B and C. Got it? All right, what's the first thing I need to do then? First thing we did was find our difference. After we found our difference, we then did what? Found our common ratio. After we found our common ratio, we then identified our what? Our initial value. And then after we found our initial value, we did what? We plugged in and saw for D. Got it? All right, go. Doable? Yeah. All right, so the first thing you should did here was found your difference. So when you found the difference, you had 8, then you had 24, then you had what? 72, then you had, huh? 216. So then when you found your common ratio, 24 divided by 8 is 3. 72 divided by 24 is 3. 216 divided by 72 is 3. Yay. So we know our A equals 2, and we know our B equals 3. Choose any point other than that one, right? Again, why would you choose large numbers? I don't know, because you're weird, maybe? And you just like to give yourself more work? Choose smallest numbers possible, right? So I'm going to use 1 and 10. So we know that 10 has to equal 2 times 3 to the 1 plus D. So based on this, D has to be what? 4. So our equation should be y equals 2 times 3 to the x plus 4. How we do? There we go. All right, really quick. Just tell me what the last equation is. Y equals what? Minus 0. Minus a half? Okay. Just make sure. You're geniuses. All right, good?
Yes.
All right, here we go. Moving on. Modeling exponential functions from data. So an exponential model can be constructed if we are given either the common ratio and the initial value, which we just did, right? We had our common ratio and our initial value, or given 2 points as an output, we can find the initial value and the base and the common ratio from these two values, okay? So that's all you need to establish an exponential model. Now, that's all you need also to establish a linear model. So you have to use a little bit of math sense to determine if what you're representing is linear or exponential, right? What type of growth do you see happening? All right, so let's start here. We have T for T is greater than or equal to 0, less than or equal to 30 minutes. The number of fans inside of a large sports stadium can be modeled by the exponential function f of t equals a times b to the t, where f represents the number of fans inside the stadium, and t minutes I'm sorry, I can't talk. After the doors open. There we go. There are 47 people in the stadium 2 minutes after the doors open, and there are 2,602 fans in the stadium 20 minutes after the doors open. Use the given data to write two equations that can be used to find the values for constants a and b in the expressions for f of t. This is an example of a possible FRQ. They're smaller numbers, but when they ask you to establish the example, the two equations, you're writing two exponential models. Does that make sense? That's because they're giving us enough information. They're telling us it's exponential. So the first thing we're going to do is write our two equations that we could use. Your two equations are going to be based off that you have 47 people after 2 minutes and 2,602 fans after 20 minutes. Yes? So we're establishing our A times B to the T. All right? So our first model is going to come from our first piece of information, which is the 47 people. 47 is our dependent, right? Our range, our output. So we have 47 equals, we don't know the initial, right? Agree? We don't know our B, but we do know that it's after 2 minutes. Does that make sense? So that's all we can plug in thus far. Then we're going to do the same thing for our second equation. So our second equation that we would establish is 2,602 equals A times B to the 20. Okay. This would be on the calculator part of the FRQ. But if you do not have these two equations written, you do not get full points for that. Even though you can do it in the calculator, they're not going to give you your full points if you do not write the two equations that need to be created. Does that make sense? All right. Was that terrible to create our two equations? No, it was not. So after you've created your two equations, the next thing you can do here is, how do we solve systems? A few methods. We have substitution, right? We have substitution. If there was terms, meaning I'm adding and subtracting, I could do elimination. But am I adding or subtracting here? No, there's no terms. There's only factors. So therefore, we cannot use elimination, but there's substitution. So you can start by figuring out A and B through substitution. Does that make sense? So you're going to have to substitute one of those variables in for the other. It doesn't really... I'm going to solve for A, substitute A in. Does that make sense? Okay. So we're going to substitute. So we established our two equations. Now we're going to solve for A. So to get A by itself, I'm going to use the smaller A. To get A by itself, all I need to do is with B squared. Divide. So we know that A equals 47 divided by B squared. Does that make sense? Because all I need to do, opposite of multiplying, is to divide. Now I'm going to substitute that into the other equation. So we get 2,602 equals, instead of A, I'm writing 47 divided by B squared. 47 divided by B squared times B to the 20. All right, now we're going to clean this up. So cleaning that up, we get 2,602 equals 47 times B to the what? To the 18. This is division. I have B to the 20, B to the 2. What do you do when you're dividing and the bases are the same? What do you do to the powers? You subtract. So 20 minus 2 is 18. So we simplify. Now our goal is to get B by itself. So to get b by itself, I'm going to divide both sides by 47. Okay, when I divide by 47, let me open up Sylvie. All right, so we have 2,602 divided by 47. And we get not such a pretty number. So I'm going to leave it as a fraction, which is just 2,602 divided by 47. Divided by 47 equals b to the 18. Okay? How do I cancel out a power? You can take the root, or there's another option. It involves multiplying. There we go. We're going to multiply by the reciprocal. If I'm 18 over 1, what's my reciprocal? 1 over 18. And what I do to one side, I'm going to do to the other. So that is what your b value is. So now you have the exact answer for your b value. You have the exact answer for your a, you have the exact answer for your b, and that's your exact answer. Well, you can find the exact answer for your a. Okay? When you are doing this, this is going to be on the calculator part. If they do not see these calculations and they just see your final equation because you did a regression model, they're not going to give you full credit for that problem. The regression model can be your way of checking yourself, but you have to have the work showing that you understand how to do the calculations without a regression model. Does that make sense? Okay. So if you don't have these, then you're going to be like, they're like, oh, well, only 1 point for you instead of getting the full 6 points for their problem. If all you did is write the regression model, that's all they're going to give you credit for is that 1 point. Okay. Does that make sense? All right. So now that we did all of this, I could write I'm going to write my exact value problem out, and then we'll simplify it in the calculator. So putting it all together, I know that y equals my a, right, is 47 over b squared. And we know the exact value of b, correct? The exact value of b is 2,602 divided by 47 to the 118. That's the exact value. Okay. Notice I'm emphasizing exact value. You want to use exact as much as you can all the way to the end so that your decimals are precise. Make sense? All right. So we're going to plug in our A, but instead of B, I'm plugging in what? 26,002 over 47 to the 118. Now, when I do that, I want you to notice what I'm going to do here. So I have 47 over 26,247. That looks a little weird. Why did I write to the 1/9? I wrote to the 1/9 because this is b squared, right? And when I square 1 over 18, that becomes 2 over 18, right? By square, power rules, parentheses, right? It becomes 2 over 18, and 2 over 18 reduces to what? 1/9. So notice that I simplified that. So let me write it out for the ones who are like, Miss, what the Hades are you talking about? So we have 47 over 2,602 divided by 47. And it already is to the 1/18th. And now I'm putting it also to the 2. So 1/18 times 2 is 2/18ths, right? And that reduces to 1/9. Okay. And then all of this times our B. And what's our B? Our B is 2,602 divided by, that looks like I'm subtracting and I don't want to, so I'm going to use parentheses. So there's no confusion. Times, that's not a 7. You saw nothing. And then 1/18 to the x. So that's our exact. And then you're going to just plug each piece in to get your approximate A and B value. So using a calculator, our A is going to be approximately, I need Sylvie. Is this easier to model with Sylvie on the screen and not have Desmos go back and forth? So I'm going to have 47 divided by, and I have 2,602 divided by 47 to the 1/9, right? So we end up with, that's our approximate A value. We're going to then have our approximate B value. And what am I going to do for the B value? There we go. So we're just doing the 2,602. 2,602 divided by 47. And we're doing it to the 1/18. 1 divided by 18. So that's our approximate B value.
Amazing. I needed that 28. But just can I ask a question quick? Okay, sorry for interrupting, but is there an agenda for December 1st when we come back? The first part will be like an avid panel and we'll talk about how to use Ripple strategies. The next part is going to be writing across the curriculum. Somebody told me you were like the guru of focus notes. And so we were wondering if you would present with the student, and I'll ask Ms. Miller to come talk to you more about like what the vision is, but we were wondering if you would be interested in it.
I can't. I just don't know what style of focus notes y'all are wanting.
So the whole purpose of this is to see your teacher strategies for writing. Like even if you're not a English teacher, this is how you can embed more writing in the lessons, basically. And so one thing we was talking about focus notes. We would like to come like have it from your perspective, just so it's not being, it's not no again, it's not just us saying it, but this is how it's actually going to be used. So.
Okay. I mean, I don't mind. My focus notes are more like not necessarily. I don't know. That's what, like we have a lot to write, and so therefore you can kind of see like your interactive notebooks and how it's.
Let me let me
so I mean
to come over and y'all chat.
I just don't want to show what I do for focus notes and it's wrong.
You feel like it's not Avid style?
Yeah, I don't know if it's necessarily Avid style type of focus notes.
Okay.
Okay. Well, like with the extra colors and the marking of the text and things of that nature.
Some of the schools that I went to, the only thing they were using was the form, and the students were writing like summaries, and then they
so like the Cornell notes format. Yeah. So I don't really use the Cornell notes all the time. Okay. Well, actually, not that much because it wastes paper with how much I have to make things smaller to fit in the format.
Okay.
We'll do like QCCs around our notes, but we don't necessarily
use that particular style. Okay, I'll let her know.
Yeah. So I mean, I'm down to do whatever you need me to do. Okay. I just don't want to.
I hear you. I hear you. Okay, let me tell her that, and then I'll tell her you're willing, and then I'll tell her
Yeah. Just let me know.
Okay. Appreciate you.
Yes,
thank you. I'm sorry.
Of course. No, you're good. Oh, I was recording still. Ignore that in the video when you watch it, guys. All right. So back to where we were. So when we were here, our A is approximately 30, and we're going to round to the nearest 3 decimal places. And our B is approximately 1.250. Okay. So notice how I put that 0. That lets me know that I had a value that caused a 9 to round up. Does that make sense? All right. Now, was that terrible? All right. Tell me why it was terrible. I did not. I will give you that. I did not leave out enough space, and I thought about it after I made the notes, and it was too late for me to undo it. So you do not have a lot of space, but you do have like space on the other parts that you could write in. You also can grab a sticky note or a note card from the table, add some extra stuff in there, like create your space. And so just kind of problem solving the lack of space. That's a student fixed thing you can do. I will take that. But as far as space, ignoring the fact that there's space, what step in the process are you stuck at? That's what's more important. So, okay. So, step 1, we'll refine it. Step 1, setting up the 2 equations. Okay. Because they told us what our model for our equations needed to be, correct? This is where it goes into knowing what's your input and what's your output, correct? So, our input was our time, our output is our people that are there, our population, right? Okay, after you do that, step 2 was then deciding which one of these variables you're going to solve for. I'm going to tell you right now, you're going to always want to solve for A, because if you're solving for B, you're going to end up with a fraction as an exponent versus just a fraction as your whole number, quote unquote. Okay, so we solve for A on step 2, where we lost at solving for A and the smallest number. Opposite of multiplying is to divide. So we divided both sides by b squared. So A is now by itself, which is how we got 47 over b squared. Okay. After we found our A, we substituted for it in. So we isolated a variable, substituted. So A, we substituted into the second equation, the unused equation. Yes? Did we see that? Legitimately or no? Okay. So we substituted. All I did was say, oh, you're A, swap. It's a substitution. Once we substitute it, we're now down to solving for our second variable, which is our B. So solving for B, we're now using inverse operations. But before we start that, we went ahead and simplified. Does that make sense? If I have B to the 20 divided by B squared, well, that's 20 minus 2. And 20 minus 2 is 18, which is why it simplified down to be 47 times B to the 18 using exponent laws. Okay, now we're getting B by itself. So the opposite of multiplying is to divide. We divided both sides by 47. Okay, once we divide both sides by 47, the opposite of a exponent is its reciprocal. So if I need to get rid of 18, the reciprocal of 18 is 1 over 18. So I multiplied both sides by 1 over 18. Now B is by itself. What I do to one side, I have to do to the other. So this is it. If you stop thinking about fractions as fractions and think about this is just a division problem that we have yet to do. And that's because we're trying to hold on to our exact values, which is why we haven't did it yet. That is all the fraction is a division problem. This is 2,602 divided by 47, because isn't that what we did to get this? It's just division. And now we have our B. So we have our exact value for our B, our exact value for our A, which we simplified. And then we plugged them back into the equation. A is this. B is this. So from the calculator, I can find the approximate values of A and the approximate value of B. Question. Okay, remember, If this is one of the calculator FRQs they choose to use again, it has been used twice. Calculator questions like this twice. And if they choose to use it, you have to have the work leading up to the calculator stuff. If you only have the calculator stuff, they're only going to give you partial points. I mean, partial is better than none, but the work itself is just showing, okay, yes, I understand why this is going to work, why this goes into the calculator. Okay. So they are expecting you being given 2 points to be able to do an exponential algebraically. All right. The next one. The next is just regressions and Desmos. So you have a quick write box on your paper. In that box, it says write your summary of how to use Desmos to find an exponential regression model. I didn't write all those words on yours because I didn't need to. But how do you find a regression model? Yes, I didn't. How do you find a regression model using Desmos? So that's kind of like your little tidbit to remind yourself, this is how I do it. Because we've been doing it over a year now. So there's no point of me like reiterating it over and over in steps. We are going to model it, but yeah. Okay. I'm going to first model it with you guys using the one we just solved. And then on example 3, you're going to use it. You're going to do it on your own. Does that make sense? Okay. So I'm going to go to my Desmos. All right. So I'm going to be using, go back. Our points from here. So the 247 and the 22,602. So here's my Desmos. I'm going to add my table. And we have 247. And we have 20. And we have 2,602, right? Okay. I'm going to hit this. Boom. That just zooms in on my points. Now I'm going to run the regression. Here's my regression. I'm running an exponential. And bam, were those not the values we got? They were. Those were the values that we got. Okay. If you only put this, you're only going to get 1 out of the 6 points for that problem. If you only put this, you're only going to get 1 out of 6 points for that problem. It is, but you're only going to get 1 out of the 6 points because they're expecting you to show that you can do it algebraically.
What if you show the wrong or you get the right answer?
You'll get that 1 point because they're going to be like, oh, they went to regression. Okay. Again, some points are better than no points. Depending on what kind of work, like if it's an obvious mistake that they can address, then they'll give you something. But yeah. All right. Yes. Doable. All right. So on example 3, making sure you are comfortable using Desmos. We're going to practice at least getting 2 points on this problem. And the way we're going to make sure we can get those 2 points is at least by setting up the 2 possible equations, right? Whether you use them or not, can you at least set up the 2 equations? Okay, that's another point that you can get. Does that make sense? So, okay, you set up the 2 points and then go ahead and you can use your Desmos, or if you like to challenge yourself, find it algebraically. All right, go. All right. We're going to go. Keep going. Ignore me. All right, here we go. So it says that we're establishing g of x equals a times b to the x and asks for our 2 possible equations if we were to solve this algebraically, correct? So we have said values for those two possible equations, right? So your first equation would be 21 and 54 equals, and you're going to have your A times B to the 3, correct? Your second equation should be 3 and 62 hundredths equals A times B to the 8. Did you at least get those? Yes. Did anyone challenge themselves to try to solve it algebraically? Perfect. All right, let's see. Which one did you choose to solve for A? Y'all chose the big numbers? Okay, that works. So you get your A equals what? Perfect. Okay, so we found our equations. We found what we're substituting in. And then what do you substitute this into? The other equation, the equation you did not use, is where the substitution takes place. Okay, so now we're going to substitute that in. So we end up with 3 and 62 hundredths equals 21 and 54 hundredths divided by B to the third times B to the 8. Can I clean that up? And how do I clean it up? Subtracting the powers. 8 minus 3 gives us 5. So we have 3 and 62 hundredths equals 21 and 54 hundredths B to the 5. All right, what do I do next? I heard it. Someone said it. We're going to divide. So step, where'd my pen go? There she goes. Okay, so now fourth step is to find our B, right? B makes it all work here. So our B, that's not a 4. You saw nothing. So B equals what? There you go. Now, was it terrible? All right. So you have your B, and then you have your A. No, you'll put it in the calculator. For not finding A and B? Yeah. You didn't finish it. All right, and then your A. Your A is a little different, though. What is the exact value for A? Over 21.54 to the 3/5. So these are our exact values for our A and our B. So we're definitely getting full points because we did all of that. Yeah. So remember, to cancel out an exponent, you multiply by its reciprocal. So the reciprocal, we multiply by 1/5. And what you do to one side, you have to do to the other. Mhm. All right, so after we do that, we now go to the calculator and plug in to find those exact values because we are geniuses and we've earned our full entire points for this problem. And if you're not sure and you have some time left, what do? You quickly run a what? Regression model and say, oh yeah, I did it right. So we have 21 and 54 divided by, and we have 3 and 62 hundredths divided by 21 and 54 hundredths, all to the 3/5 power. So that's our approximate A value. And then our approximate B value is 3 62/100 divided by 21 54/100 to the 1 divided by 5. And our approximate B value is, and that makes sense because it should be a decay. So A already had a 3, and we substituted in the 1/5. So when you have two powers next to each other, that means you multiply. So 3 times 1/5 made it 3/5. Dude, did test.
Oh, that's before you leave?
You guys said you didn't want to do it the Tuesday we came back.
Yeah. Hey, you know what?